right? Area of a circle, pi r squared. Okay, so we are going to do. When it's drawn like this and it's kind of put in the middle, I think that is permission to interpret it as the diameter. So what do we know about the radius? It's half. Okay, so our r is going to be 3. Okay, so we need the area and their circumference. So let's remind ourselves what the formulas are. Okay, so area pi r squared. Circumference? 2 pi r. Okay, if you're fancy, you can use the alternate one, which would be diameter times pi. Or pi times diameter, I don't know. Which way is it? Is it like this? Okay. It doesn't matter, multiplication is commutative. That's not my favorite. I like the 2 pi r better. Okay, so let's do it. Let's plug in our radius. That's all we needed. So area equals pi times 3 squared. And we're leaving answers in terms of pi. 9 pi. That would be inches squared.
Oh, we're leaving.
Yes. Okay, so if it says in terms of pi, that's exact. All right, circumference. So 2 times our radius, which is 3 with a pi. So 6 pi inches. Okay. Circumference is like the amount of string that it would take, like the length of string to go around the circle, right? It's the, if you got a ruler and like kind of rolled it around the edge, it's a linear length even though it's wrapped around something round. Okay, so this needs to be a linear dimension. Okay, the power is 1 for linear, right? Algebra. Okay, this is 2-dimensional units. I'll go back to pink. This is 2-dimensional. It's an area. Era. Okay, spell much? Okay, questions? Okay. What do you guys think we should do here? What information did we need to find the circumference?
The diameter or the radius?
The diameter or the radius. So we need the R. Okay, but they didn't give us R. They gave us the area. Do you think we could maybe solve for the R? Okay, so let's do it. Let's use the formula for area. Pi r squared equals the area. Plug in this for that area.
And then you divide by r.
Okay, what happens to the pi's? They do.
I cannot draw a pie.
Yeah,
It's
that's what I
so
was
bad.
saying.
It takes practice.
Okay.
Okay. Now what? Yeah, is this something at this point we can do in our heads? We know we're going to get a positive and a negative, right? So R is going to be, what is it, 17 and negative 17?
Yeah.
Okay. Can it be the negative one?
Yeah.
What?
Yeah, negative 30.
The radius is a length. He plugged it back in to make sure it would, if you use the negative one, it would still give you the right area, but we need it to be positive, so it's a length. Okay, so the radius is going to be 17. So how can we use that?
2 times.
Yep, plug it in. And it says exact, so we're going to leave the pi in it. So 2 times 17 is what? Okay, 34 pi inches.
Hooray.
Hooray! Okay. Okay. So we just want the shaded region. Any ideas?
Find the square.
Okay, find the square. Okay, ooh, okay, I like that. 16 is not just the side of the square, it's also the diameter. So what is that of the circle, right? So what about the radius? Okay, I'm feeling like there's a plan forming. We're gonna get the square and then do what?
Get the circle.
And do what? Yeah, subtract. Okay.
Yes.
So we're basically gonna do square minus circle. That's the plan.
Oh, this is fun.
Okay, so how do we find the area of a square?
Base times height, length times width.
Yeah, length times width, base times height, and they're both 16, right, if it's a square? So 16 squared minus, what's the formula for the area of a circle? Pi r squared, and the r is 8. Okay. So our area left is, or shaded area, I should say. Let's round to the nearest hundredth because that's what the directions say to do. So I'm doing 16 squared minus pi times 8 squared. I'm getting 54.94.
Yeah.
Meters squared. Okay, now using that as an example, do you see that this problem is just that problem on steroids? Okay, I want you to try it. Okay, so if this whole thing is, what's the diameter?
10.
If the whole thing is 10, what is the radius?
5. I got 7.5. 25 squared. 25 squared. You silly goose.
Okay, is this what you guys put in your calculators?
Oh.
No.
There is.
25.
Okay, so what is our area left?
Caroline. Oh.
No one's gonna tell me?
Wait, I don't think none of us put that. Wait, I forgot.
Did you forget the 12?
It's 257. Yeah.
Okay, that's what I got too. 257.52 inches squared. Okay, don't forget to write a sentence. That was a word problem.
Oh.
If you feel like you don't want to write the answer twice, just put the answer in your sentence. You know what I mean? Like, I'm not trying to waste anybody's time, but you get a point for the sentence. But if your answer is in the sentence, it's still right? You don't have to write it twice. Okay, so with the next part, we're going to take another little trip down memory lane. Okay, in Unit 3, we did some work with circles, right? Some of you are maybe still traumatized. Others loved the circles.
My favorite.
All right, hold up. So when we did our circles unit, we talked about the measure of a central arc. Okay, this is not. We talked about the measure of a central arc. Like if I told you that this angle right here was 95 degrees. What is M? 95, okay? So then M would be 95. Okay, we talked about the relationship between the intercepted arc and the central angle. So we also did something that was arc length, where the measure wasn't in degrees anymore, it was in like centimeters or inches. Okay, so what we did was an arc. Okay, and then in this case, it would be the arc from A to B, arc AB. We're going to use the same diagram. It's going to be double duty. Okay, and then we had a formula for arc length. Okay, if you want, you can call it S because that's its little symbol. So what we did was we took not the whole circumference of the circle, but only these 95 degrees of the whole circumference of the circle, right? So we took the circumference, 2 pi r, and we multiplied it by m degrees over 360. You guys remember this?
I do. This is like the one
I do.
So this is its two-dimensional analog. It's basically the same formula, but what are we swapping? Yeah, we're swapping out the circumference and putting in the area formula instead. So just like this gave us only this part of the circumference, this formula gives us this little wedge of area. You see how they're basically the same?
Yeah.
So like you only really have to memorize one formula, but just know that if you're doing the arc length, you use the circumference. If you're doing the sector area, then you use the area of the circle instead of the circumference. Okay, perfect. Let's rock and roll. All right, so we want to find the area of our sector and the length of our arc. So let's just use the formula. So we want area equals pi. What's our radius?
20.
Okay, square the 20 times, what's our angle?
72.
72. Well, because that's the arc measure, so that also tells us the central angle. Right? Remember that they are the same measure. They're not congruent because they're different figures, but those two different figures have the same measure. Okay, so 72 out of the 360 degrees around the whole circle. We only want that part of it. Oh, crap. Leave your answers in terms of pi, so don't put a pi in there. Okay, I'm getting 80 pi. Make sure you know how to do it on the calculator. Test yourself. These will be centimeters squared because it's an area. You put the pi in. So you can just divide away the pi if you want, so you don't have to redo the whole thing.
8 pi squared.
Okay. Now we're gonna do the arc length. So S or arc ZM. We're going to basically do the same thing, but we're going to swap out area for circumference. So 2 times pi times the radius, which is still 20, times the same ratio, 72 out of the 360 degrees. All right, crank that out. Leave the pot. I got 8.
Tell me what I got.
I got. Everybody get 8 pie?
8.
You better put that phone away before I call the phone police. Okay.
What's up, though?
Okay, now we want the shaded sector. Did they give us the measure of this that central angle? They gave us the other one. So what do we have to do to find the angle for the shaded sector? Yep. So if we want to find this angle, we have to take the 152 away from 360. $208. Okay, so now we can just use the formula. Radius is 10. I'm using 208 of the 360 degrees around the circle. What? Oh, I used the circumference. Oh, just making sure you were paying attention. No, that was like I literally just messed that up. That actually happened. Thank you. Pi r squared. So 10 squared.
So when it says area, you use pi r squared, and when it says length, you use 2 pi r.
Yes, because that's the circumference. Yep. Okay. What did we? Oh, this time we get to round to the hundredths. All right, I got 181.51. Is that what you guys got? Okay. Centimeters squared. Okay, so that one we got to round. Example 7, we are doing in terms of pi and rounded to the nearest hundredth. Did I skip that part on the first one? No, I did not. Huh? Did you do the whole thing? Do number 7. I want your answers 2 ways, in terms of pi and rounded to the nearest hundredth. You're doing the area of the sector and the arc length. Oops, that's supposed to be J what? JH? I can't see on mine. Yeah, that's supposed to be JH. Can you tell I copied and pasted?
I got this. We're actually in the area.
I'm getting 52 pi squared. And then I can just multiply that by pi, and I get approximately 163.36 meters squared.
Stop.
Did you get it?
Stop doing that. No.
to.
Oh.
Scattered, I can
Okay, so when I put this in the calculator, when I put this in the calculator without pi, I'm getting 8.6 repeating. Okay, so I want that as an improper fraction. So I'm gonna do math, enter, and it'll reduce it as a fraction for me. So that gives me 26 thirds pi, which is approximately 27.23. Is that the end?
I think we should go on to 4A.
No, we're done.